Hello everyone. In this video, let's see how we can integrate Amazon S3 with Serverpod. And to do this, we have to configure a couple of things. And let's get started. To do this, first let's create a hosted zone. And for this, you have to search Route 53. And here is the Route 53. Go inside that, and this is the Route 53 dashboard page. Go inside the hosted zone, and there you could see a button for creating a host zone. Click on the create host zone and type in your domain name, and that's it. We'll create a host zone with our domain name and click public hosted and create zone. Next, let's create certificate for our load balancers. So go to certificate manager, and in certificate manager there is a button for request. So click on the request to get a new certificate and select public certificate and click next. Here let's type our domain address. So my domain is ajk.xyz, so you should enter your domain name, and we also add a wildcard before our domain name for the subdomains. So this is very important. You add that wildcard before your domain so that Serverpod will be using the subdomains for various resources which is created by the Serverpod. In validation method, we have selected DNS validation. So once you click create, it's going to give CNAME, and you have to add those CNAMEs to your naming server. And then we have created our certificates in US West too. Now you have to create that same in US East. So follow the same steps and create a certificate in US East, and then let's create the security keys. Click on the profile and go to security credentials. In security credentials, if you scroll down, you could see access key. Click create access key and create your access key. We'll be using this in CLI, so it's warning us because we are using root account user. You can ignore this or create a IAM account and create access key for that. So our access key is now created. Just copy the access key and secret key and store that safely. So we'll be using that in Serverpod and Amazon CLI. So now let's go and create a Serverpod project and open that in a VS Code. So let's create Serverpod with Serverpod create command, and it's created. Let's open that in a VS Code. So we have loaded our project in VS Code, and let's start to make changes in the Serverpod. First, let's go to the server folder, and in server folder let's go to the config, and here we have a password.yaml file. In the shared passwords, we have to add our AWS keys which we created. So let's do that. So here we have to add AWS access key ID and AWS secret key. So let's remove this and add our values. And we have the key here. Let's get the key ID pasted here, and we have the secret key, and let's get the secret key and use it here. So you have to use your IDs. So we are done with the access key, and we are done with the secret, and next what we have to do is you have to go inside the AWS, and we have this Terraform, and in Terraform you have config auto. So in config auto we have a couple of things which we need to take care. So here we have the hosted zone ID, and in this you have to mention your zone ID. So how do we get that and where do we get that? But we have created a hosted zone before. So let's go to that, and I have one hosted zone here. Let's go inside that. So here we have our hosted zone ID. So go inside the zone, and if you click on the hosted zone details, you could get the full ID. Just copy this full ID here. So instead of host ID, we are going to use this here, and the top domain. So this is where we are going to specify our domain name. So that's it, and the certificate ARN. So this is where we have to specify our certificates. We need one in US West and we need one in US East. Go inside the certificate, and you could see the ARN value here. Just copy the ARN value. I'm going to paste this in US East. So now we are in US West too, and we also have a certificate here. So just copy this certificate here. So we have to install the AWS CLI in order for us to execute the Terraform. So here are the steps which you need to follow to install the AWS CLI. So just install the AWS CLI based on your machine type. So for me it's Mac, so I will be using this step. So first I have to download this. I have to run this command. So the setup is done. So that's it we have to do. And then you can run these commands to check whether the AWS installation is done properly or not. So once the installation is done, next you have to go to configure AWS CLI. So you have to configure the CLI. So you have to run the command AWS config, and it's going to ask the AWS access key and the secret key and the default region and the output format. So this is the Terraform official webpage, and what you can do is just see how to install Terraform based on your machine type. So once the AWS and Terraform is done, we are good to go. So I'm in the server directory, and in server directory you could see we have a AWS folder and a Terraform folder. So we need to move to that folders AWS, and I'm going to move to Terraform init. So our Terraform init is completed, and then we have to run Terraform plan. So it's going to ask our database password. So it's going to ask like the production password, and let's provide that. And the staging is also same, so I'm providing the same value. Now we can execute Terraform apply. So again it's going to ask the database passwords. I'm going to provide those things, and it's going to ask for the confirmation. So it's going to take a time. So our resources are completed, and it took a long time. So you could patiently wait till that gets completed, and for me it took around like 10 minutes. And here before we start our serverpod, we have to add the configuration for S3. So let's go to the documentation page, and you could see the snippet for configuring the S3. Just grab this, paste it here, and it's going to say like we don't have S3, so let's import that. And while importing, it's again going to say we don't have that. I'm just going to add this to our dependency. So for this, for working with S3, we need Serverpod Cloud Storage S3 as our dependency. So here you could add this in your pubspec.yaml file, and that's it. So let's go here, storage ID with public, so that we can generate a public URL files, and we could use that to share images or store, and you could use that image URL in your other applications also. So we are going to stay with the storage ID public, because we can generate a public URL of the image which we are uploading, and we could use that to show the image in our Flutter application in this demo. So let's have the public, and if you're going to not generate a public URL, and you're going to retrieve the files within your server, and you're not going to distribute a public URL with others, you can go ahead with the storage ID of private. So as of now we'll go with public, and then our location is as it is US West 2, and the bucket name. So let's go to the AWS. These are the buckets which are created by Terraform for us with the scripts which came built in with Serverpod. So let's copy this public storage bucket name, and I'm going to use the bucket name here and the public domain. So
Here it's going to be my domain. Leave the storage as it is because when Terraform created, it's going to create with a subdomain of storage for a storage related thing. So we are keeping storage and the rest is your domain. So that's it.
When we go to the documentation page, we can see a couple of methods in the server side, and the first one is get description, get upload description. So this method, what it basically does, it's create an URL. So let's copy this and we'll use this in our endpoint and we'll add that. So let's go to the example endpoint dot. Here let's add the method so that we can call this from the Flutter application. So this get upload description creates as a signed URL. So using that signed URL, we will be able to upload the files to the S3 bucket. And inside the method, we have a storage ID and it's in public. So if you want to store things in the public bucket, you can go ahead with the public. And if you want to store the objects in private, you can go ahead with private. So then we have this path. So it says in which path we have to store the files in the S3 bucket. You can go ahead with a custom path if you required, or you can go ahead with the path which is provided by the client side. So you can pass the path from the client side, or you can also add a separate logic in your server side to have your own path. Suppose if each user has to have his own path, you can use like user id before the path. You can append that with the path so that you have your custom path. So that's it in this upload description. So let's see what we need to do further. So we have this verify upload method. So this helps us to verify whether the file got uploaded or not. And we have a few things to retrieve the files, and we also have the code for the client side. And if you see the client side, you see we have this upload description. So this upload description we are getting from the server side. We created a method in our endpoint, so we get that upload description and we store that in a variable, and we use the file uploader which comes from the server pod, and we pass the upload description. So using that we create an uploader object and we pass the upload description. So we are sending a stream to the uploader object and it will upload the file, and we also have this verify method which checks whether the file got uploaded or not, and that's going to work. And we have this info, like it says we should follow the path which is compatible with S3. So you should avoid adding leading slashes in order for you to make it compatible with S3. So take note of that, and let's see what are the methods we have to access the stored files. So we have one method for file exist, one to get a public URL. We'll be using this public URL. So we also have this retrieve file method which will retrieve the byte data. So we will use this when you have a private upload, and if the file is in the private upload, you can't get that, and if it's in a public storage, you can get a public URL and you can share that. So we'll use this method to get a public URL. So let's create a method for this. We'll get the code for getting the public URL. Let it be a future of string which can be null. So let's name it as get public URL, and it's going to have session and path as a arguments, and let's make it as async and we'll paste the code here. So this URL is going to have the public URL by which we will access. So we got the URL. Now let's get the URL. We'll convert this to a string and we'll return this to the front end. So let me add a return statement, and it's good. So now what we have to do is, here we have this path, right? So it has a invalid path. Let's change to the path which is coming from the client side, and this path is going to be similar to the path for which we got the upload description. so that it should be same. So we will get the public URL. So now let's go ahead and run serverpod generate, so that serverpod does its magic to generate all the client libraries. We can just use it as a method in the Flutter. So let's go to the front end part, and inside the lib, let's go to main dot dot. In this is our serverpod template project, and I'm not going to make any changes in this, but I will be just using the call hello method, and we'll add the code for our application to upload the files inside this call hello method. So you can either clear this, and you can have your own user interface to upload the files and make it beautiful. Let's go to pubspec.yaml file, and we'll add file picker as a dependency, so that we'll able to pick files. And once it's done, we are good to go with the main.dot file. So in main.dot file, we'll add a code for picking a file. So let me complete that, and we'll see how to use serverpod libraries to upload the files. So now we got the file, and let's create a signed URL to upload our file in cloud storage. So we'll use serverpod get upload description method, which we created in our endpoint. We'll call that method, and we'll pass a path to that. And for me, I no need a path, no customized path, so I'm just going to give the file name. So if you want to customize the path where the file needs to be stored, you can add your own logic here. So we have this file uploader object which comes from the server pod, and we'll use this to upload the files to the storage. So we'll create a variable of uploader, and let's name it as file uploader, so that it makes sense. And we'll use the signed URL to get the file uploader object. So we'll do that file uploader, and inside that, if we have to pass the URL which we got, that's the upload description. Actually, the upload description should be passed into the file uploader. So since it's null, we have to write some null checks in order to prevent it. So we'll may check whether a signed URL is not null or not, and if it's not null, let's create a file uploader object, so that it shows no error now. And then what we'll do is we'll use this file uploader to upload the byte data to the storage. So we have this upload byte data method in the file uploader. We'll just get the byte data from the file picker, from the file which we picked. So let's write code for converting the file to byte data. So we got our byte data. Now let's pass that into the function. So like, now we have passed the byte data to the function, so this will be get uploaded to the cloud storage. And what we'll do is we'll make it as await, so that it waits until it gets executed. So then what we'll do is we'll get a public URL for the file which we uploaded. So for to do that, we'll call the method which we created in the endpoint. Now we got the public URL. So let's print this public URL in the console, and we'll start the Flutter project on the server pod to check whether it's working or not. So both of my web application and server is running. Let's click send to server, so that it opens a dialog to pick a file. And let me go and select the image. So let's upload this image to the server, and if we go to the console, here we have no errors, and I think it's working. And if we go into the debug console, it doesn't shows the URL because I didn't add await. It's showing the future string. So let's quickly fix that, and I will see the public URL. So let me go to the code, and we'll add await to that. So let's add. So let's restart the application quickly and check whether it's working or not. So let's again upload a file. Let me pick the same image, and let's go. So this time we have added the await operation so that it will show the URL. Now let's go inside this URL. Let's try to open this URL. So you see we have the storage subdomain before our domain. So that's why we added wildcard in the certificate creation. So when we open this in a Safari, it's downloading the file. So now let's see how we can use this URL within the Flutter application, so that we'll able to see the image in the Flutter. So let's make changes for that quickly. We'll add image.network widget. We'll add image.network image, and once the URL is got fetched, we'll use set state to rebuild the widget so that we'll able to see the image. But anyway, this may not work because we didn't set the cross rules. So keep that in mind, and if you're not seeing the image once you do the change, don't worry, we have the solution for that also. So let's try it, and we'll also fix the issue which we face after uploading the file. So now the URL is also visible, and if you go inside the Flutter application, you could see that an error. So this is because we are trying to fetch in a cross domain. Go to AWS console and go to CloudFront. In that we'll have two distributions which we created using Terraform. So go inside that, go to behaviors, and we have this one. Select this and click edit. So inside that, if you scroll down, you will see response header. So this is response header policy. Click that and set that to a simple cross, so that will able to fetch the image in the Flutter application. We also need to do that for the other distribution also. So follow the same steps and do that for the other distribution also. Select that and click edit. And if you go inside, set the response header policy to simple cross. And now let's go back to the application and restart that, and let's upload it again. So this time let's upload the same image, and we'll try to see what happens. And look, the image is now visible. So once you set the cross policy, you will be able to fetch the image in the Flutter application. So this happens only if you try to do in a web, and even without setting the cross, you will able to see the image in mobile. So that's a small update which need to be made for a web application. So what do we do next? So the next step is very crucial, and it's to destroy your Terraform resource. So just go to the console, go to the AWS folder, go to Terraform, and just delete the resource which you created if it's not required. So inside the Terraform folder, execute Terraform destroy so that all the resource in AWS gets destroyed and you won't get charged. In upcoming video, let's see how we can use this feature and make a simple project with this.